Now that we have discussed the basic workflow, we will start by approaching or by describing the basic modules or the blocks that we are going to use in Simulink. So the two basic blocks that are essential for us are mainly the ADC block and the PWM block. So first we are going to discuss the ADC block. So as you can see here, the ADC block has these settings. So we have the ADC module here. So have different modules A, B, C and D. So we have a chart in our data sheet, so we can see here there that we for the if you want to see for the ADC2, it will be the ADC module used is A, and the input channel we can configure here. It's we have a lot of options. So for ADC2 it's ADC in 2. After that we have the ADC resolution. So the resolution is as you may know about ADC, that there's a resolution for the conversion. So if we select between, we have two options, we have 12-bit and 16-bit option. But for the launchpad that is used in this product, there is only a single-ended input. So we have only the option for 12-bit single-ended input. So the resolution or the course that we are assigned for this ADC will be 2 power 12, that is 4096. So the conversion, if you want the conversion, it will be between it will be, the converter will be the range divided by 4096. After that we have the SOC trigger number. So for each module, because if we have different channels in ADC module A, B, C or D. So if we have for instance we have count for ADC A, if we have three channels, we have ADC in 0, in 1 and in 2. So if the trigger occurs, what we will we do? Do we start input 1, convert for input 1 or input 2 or input 3? So how do we decide this? So this number decides this. So SOC should be unique for each channel. So in case we have ADC in 2, so we configure it to SOC3. This means if we have, suppose ADC in 0, ADC in 1, ADC in 2, each of them will have a different SOC trigger. So if ADC in 0 has SOC1, ADC in 1 has SOC2 and ADC in 2 has SOC3. So at first whenever the conversion starts, it will first convert channel number 0, then it will convert channel number 1, then at the last it will convert channel number 3 on channel number 2. So the last conversion will be the one which has the highest SOC number. You cannot put two channels with the same SOC number here. So we have to make it unique for each channel of a given ADC module. So after that we have the SOC acquisition window. So this is the acquisition window that the ADC acquires the value of this measurement in this acquisition window. So we have to set it above 250. So it's for a good stable value, 300 is a good enough value. So you can set it for the current configuration for 300. After that we have the SOC trigger source. So we have different sources here. We can start the conversion by software. We can also start the conversion by interrupts, and other modules can also start the ADC conversion. But as we have discussed here, we have the PWM module. We want the PWM module's timer reset to trigger the ADC conversion. So we want a timer reset event to start the conversion for the ADC. So we configure this SOC trigger source for EPWM1 ADC 0 SOCA. So it will convert for EPWM1 SOC, start of conversion. After that we have the sample time, because we are generally operating on asynchronous event, because in the hardware interrupt asynchronous event. The model doesn't know that when the hardware interrupt will occur, so we can't uh, put a pre-estimated time here. So we are going to put it -1 here. After that we have the data type. So the data type is the output value. So, the output value, the output codes of this value, it's between 0 to 4096 for 12-bit. So because we have to convert this 4096 after that to a value bit of, in case it's a current, we will convert it to plus minus 20 ampere. In case it's a voltage, we will convert it to plus minus 1000 volt. Similarly, it will be in a fractional form, so we can't set the data type to this uint 8, uint 16. We will set it to single or double, so that the conversion is smooth after this, after the value is acquired from the ADC. So as we have discussed after this, that the SOC3 will be the last ADC that will be doing the conversion, because first the SOC1 will the SOC1 trigger will work, then SOC2, after that the last SOC3, which is for the input channel number 2, it will start the conversion. So we will uh, because we need the we want to start the control loop after the conversion of all the ADC, all the ADC channels. So this, because this is the last ADC, we will trigger this, or we will have an interrupt after this, so that we can start the control loop. So we configure this channel for the interrupt. The interrupt, we have two options, we can change it, four options for now. We will change it from int1 to, but we have currently configured for ADC int1, so we leave it at that. After that we can disable this value, because we don't want the continuous conversions. Whenever there is a interrupt, we want a single conversion. After that we want the conversions to stop. At the next cycle a new conversion will be triggered, so it will start again. So this is a brief overview of the ADC block.